Hello, welcome to my CSCI 3600 tech briefing. For my tech brief, I'll be talking about WebAssembly. So, what is it? Well, according to their main page here, WebAssembly, abbreviated WASM, I'll be using these two terms interchangeably by the way, is a binary instruction format for a stack-based virtual machine. WASM is designed as a portable compilation target for programming languages, enabling deployment on the web for client and server applications. So, what does that all mean? Basically, WebAssembly is a way to build really high-performance code that runs inside your web application at almost native speeds. So what do I mean by native speeds here? Well, what I'm saying is that if you had an application written in C# on your local machine, what happens is at runtime, it gets broken down into some lower-level assembly language that your compiler can then run at a really fast, efficient speed. So we want to take this idea of a low-level assembly language and put it inside of our web browsers so it, too, can also be run at a really efficient and fast speed. So how does it work? Is it a replacement for JavaScript? No, actually it works alongside JavaScript. So the idea is that for your web applications, you'll write some code inside of C, C++, Rust, and it gets compiled into a WASM module. This module then gets loaded into your web app and gets called using JavaScript. So WebAssembly was designed by a group in the World Wide Web Consortium, which is the main standards organization of the web. WASM is considered an open standard, so what that means is it also receives development contributions from Google, Mozilla, Microsoft, just to name a few, which would make sense because they would probably want this kind of technology to run inside of their web browsers. So they designed WebAssembly to be fast and also in a compile once, run anywhere kind of style. They also wanted it to be extremely secure, which they wanted to have it be more secure than just basic JavaScript. And they're able to do so with its binary format and the restricted instruction list. Also, they want it to be mobile and portable across multiple browsers so that it's easy to run on Firefox just like it would be on Chrome, just like it would be on Safari. So how is this useful? So you could take your existing C++ and Rust code and run it in your browser. Your native apps on your desktop that's written in these low-level languages can be compiled into WASM and then run on the web. So this can be useful for all sorts of reasons. Say you wanted to run a game engine like Unity or Unreal Engine in a browser using WASM. You could potentially do that. Or another example could be, let's say you built a new video format. So normally if you wanted to have your video format used on these browsers, you'd have to wait for the developer of these browsers to build functionality for your video format to be supported. Well, with WebAssembly, you could just take your video format C++ or C code and put it into a WASM module, load the module into a web app, and use the video format anywhere without any additional changes. So as more and more applications move to the web, like gaming engines, music platforms, or really any computationally intensive apps, we need a standard way of running these at near native speeds without the need for recompilation for each individual platform and browser. So WebAssembly hopes to be the solution to this issue. So I talked about some examples, but I think another really cool example is this website. So what I mean is this little face tracking algorithm website. As you can see my face, and you can see 3 different windows. So over here you can see that they're all running the same face tracking algorithm, by the way. But over here in this JavaScript window, it's running not very efficiently at all. Here in the middle, you can see they have this asm.js. It's also an assembler for web applications like WebAssembly, but it's a subset of JavaScript, which means it has to abide by JavaScript rules. And because of that, it might not be able to take some efficient shortcuts like WebAssembly can. Because it's an open standard, it can also just do whatever it wants. It doesn't have to abide by any JavaScript rules, which means that it can take little parsing shortcuts and also be compiled, as you can see, really, really efficiently compared to its competitors. So here's a little cool application. If you wanted to check this out, it'll be in the video's description. But let's take a look at making our own WebAssembly. So there's this cool online IDE for WebAssembly that you can use to run and build your own little WASM apps. It's already configured in the package.json to compile your C applications into a WASM module. So that's kind of cool. This will also be linked in the video description. So the idea here is I'm going to go ahead and make a little function that will greet the viewers of this video. So how it's going to work is I'm going to write the function in here. This project will then compile it into a WASM module, which will then be called by JavaScript and then be put inside the HTML and displayed in your browser. So what's going on with this JavaScript? Well, as you can recognize probably from class, that this is an asynchronous anonymous function. So what's happening here is we're taking this WASM module that we've made. It's not made currently. We'll run that. We'll create it in just a second. But this little WASM module, it will be stored in this little code promise constant. And then, using this little WebAssembly.instantiate streaming function, we will instantiate this instance of our WASM module, and we'll create a little object for it. So let's go ahead and run this little anonymous function real quick and see what happens. So we can build and run that. Go ahead and open up our web console. And as you can see, we have this little object that corresponds to this little module over here. So as we can see, there's some properties here that correlate to our WASM module that we made. So real quick, let's take a look at it. And as you can see, it's not really that readable. And this is kind of the same idea as that with your high-level apps, like if you wrote something in C#, you're not really worried about what the assembly looks like. The assembler takes care of that for you. And the same idea goes here. You're just worried about your C application. And the idea is that you can just easily import your C code into this WASM module. And then this can then be called by your JavaScript and used for whatever purposes you need it in your browser. So for the sake of this demonstration, we won't be doing a whole lot in here. We're not really going to write WASM code because you wouldn't really be using this technology for that purpose. So let's go ahead and make a little function I was talking about. At the top, you'll notice there's a little WASM export constant. And what that is for, I'm going to call this tech briefing greet, by the way. So what this little constant appears for is just to basically say, hey, when we build this WASM module based off of this C code, we want to include this function. So all I want to do is I want to return greetings, tech brief viewers. All right, and what's going to happen is it lets me build and run this again. So it's finished. And boom, look, in our WASM module, it's updated. And we can see, here it is. So how do we go ahead and use this and present this in our browser in a meaningful way? Well, here's how we're going to do that. First thing to note is that just similar to assembly, WASM doesn't currently deal with strings. It really only deals with number values. So we're going to have to interpret those WASM number values as strings using JavaScript. So here's how we're going to do that. So as we can see in our little WASM module that was compiled, we have our little string that we wrote. So we want to be able to obtain this in the JavaScript. So as you can see here, this corresponds to some address in the module that contains this data that we want. So we're going to have to somehow find it and use it in our JavaScript to present here. So how are we going to do that? Well, since it gave us an address, what we're going to go ahead and do is create a little buffer. So I'm going to go ahead and get rid of this right now. So let's go ahead and call it const memory buffer. And I'm going to want it to be a array, because all a buffer is, and for anyone who's familiar with assembly code will know that your offset, your memory, is really just an array. Items in memory are like an array. They're just stacked right next to each other. And what we're able to tell here is where the starting address or of where this string is located. So we want all of the data in this WASM module. So we're going to get that by grabbing, so module dot, let's see here, instance. And of course, this is going to correlate to what we see over here. So I'll see if I can try to, doesn't seem to want to be working. Oh, it's over here. So it will correlate to the properties over here. So as you can see, here's our tech brief greeting function. So we want to grab this. So let's go to instance dot exports dot memory. Sorry, actually, we don't want to grab this just yet. We want to grab just all the memory that's found within here to grab this string. Memory dot buffer. So this is all the memory in our WASM module. Now you might be thinking, well, we don't want all the memory. We just want that specific string for that function. Well, we're going to grab that. So we're going to make a pointer to point to that location in memory. Pointer. So how are we going to obtain that? Well, through the module properties, module object properties. So let's say module dot instance dot exports dot and then the name of the function, which is tb greetings. Greeting. All right, so this is a pointer to the array index of interest in the WASM array above. So this little buffer I made contains the memory of all of the data in here, but we just want this right here. So great, we're able to point to it. Now we actually got to do something for it. Or sorry, do something with it. So, like I said before, WASM doesn't have this concept of strings, so we're going to have to obtain the string using JavaScript. So I'm going to create a little local variable. Let's call it stringy. And I'll set it to null for now. So how are we going to obtain that greetings string that I made? Well, we're just going to run through the little buffer array that we made. So we're going to have some indexing variable I, and we want it to start at pointer, which is where the string starts. Then we're going to write a buffer. And yeah, so the buffer at the index of the pointer is where we'll start. And then we're going to want to increment it. Okay. And you might be wondering, like, hey, where is the ending condition for this for loop? Basically, when we reach this little null byte here, it'll know to stop the for loop because this is the null byte that's represented. So, what are we going to want to do here? Well, I'm sure you probably have an idea. What we're going to want to do is just concatenate each item that we find. So, stringy plus equals, we're concatenating, plus equals, concatenating our string by running through each index of the buffer that we made based off of the WASM module. Buffer. All right, cool. So now what we should see, I should say stringy, because that's what I called it. So now, cool, we have it. But what are we going to actually do with it? Well, finally, we can present it to our HTML. And this should look familiar as well to everyone. Document.get element by ID. And I believe it was called, yes, container. We want it to show up here. In container, we will put container is where we will put our text content of stringy. All right, so when I go ahead and I run this again, what comes up? Oops, looks like there was a small little error. Oops, forgot to write new here, my bad. Let's run this again, and boom, in our browser shows up what we wrote. And notice, this wasn't written in the JavaScript, this wasn't written in the HTML, this was written in C code, which was compiled to a WASM module, accessed through JavaScript, and then presented through to HTML, which we can see in our browser. Now this might be a little small example, but I hope it highlights how we can take some pre-existing technologies written in C code, and we can very, very efficiently and quickly present this information in the browser. So I hope this kind of highlighted I hope this highlighted how WebAssembly could be a cool product and how something that we should be paying attention for. So thank you for watching my tech briefing.